thanks for the wait. I'm going to try to speak faster to not delay the talk very much. But what I wanted to talk today is about front-end architecture. There's not a lot of content out there, or at least compared to back-end architecture. So hopefully, in the context of Edpuzzle, which you'll see we're a small team, but the product is quite big, how we tackle front-end architecture is something that can trigger your ideas so that you can apply maybe the same mental model, not necessarily the same solution to your projects. So I'm going to structure the talk first, talking a little bit about architecture in the front end as a general topic, then give you a little bit of context about Edpuzzle, basically our usage, the kind of product we have, what are our challenges, and which team is behind everything. And then our solution, discussing a little bit our current state of affairs, and also describing what we did wrong in the past that brought us to our current solution. And finally, if there's Q&A, great. Otherwise, we can go have dinner. So architecture in the front end. First, let's define it, because it's one of those buzzwords that is repeated. There's so many in our industry. Is it a role? Is it not a role? What is it exactly? I'm going to give my opinion of what it is. You can disagree and discuss it later together. But for me, it's basically the high-level design decisions that defines, basically adds an index of words that you can use in your system to define the different components, how they interact, and the constraints. More than the principles is even more important, the constraints you apply to yourself and as a team to guide the evolution of the project instead of just winging it as you go along, right? And this is always super contextualized, as I said before, depending on your team size and topology. In our industry, I've said this in other talks before, usually the harder the architecture of a company is, the bigger the team is behind the company, just because of the survival bias of companies who get big teams and big products are usually the ones that raise a lot of money. But these are two different variables that can be different in the context of different companies. And I'm going to explain the example of Edpuzzle as well. Why does it matter? I mean, this is the software crafters meetup. We can say because we love being crafters and stuff like that. But in the end, we want our products to succeed. Of course, I want to feel proud of myself when I write the code. But in the end, the true reason why architecture matters is much more broad. Basically, because you want to avoid the evolution of your product to stall and put the company at risk. This, I would say, as a CTO, the role that one of the major responsibilities of my role, which is in the end, make sure that the product strategy is never slowed down or blocked by basically having bad technology and running the product. And architecture plays a major role there. There's also, when I say putting the company at risk, especially now that everything's changing again, you might not think that bad architecture puts you at risk, but it might make you evolve slower. So the opportunity cost that you're paying by not being able to change your product now that everything's changing, it's hard to measure, but it's quite big. Also, you all know, you're developers. If the architecture is bad, your day is not so good. So this is very, very real. You can feel it. And it's a great symptom to detect that something needs to change. And also, in many cases, the quality of the product might even degrade. Like the maximum UX that you can reach is actually not the ideal one just because of how things are organized, and your users might be able to feel it. We have all used products that are not so good, and it's not because the people behind them wanted it to be bad. Maybe there's a constraint, an initial decision that they're dragging that is causing that, and they cannot change it unless they do a re-architecture with the work that entails. And why have we evolved the front-end architecture less? Why is it talked much less compared to the back-end one? This is completely my opinion. Again, you can disagree. But the reasons I have found thinking a little bit about this is because front-ends tend to change faster than back-end. So because you redesign, a new feature, and then change the whole page, etc., you kind of clean up more your bad code and replacing it with more bad code maybe, but it still doesn't give you the chance to re-architect the previous one. This is one of the reasons. Also, the border of what front-end is or is not so clear. We've seen with the rise of SPAs that the front-end and the back-end were basically one side of the network chasm, but later on with technologies like Next.js or even before Next.js, the API layer has also been added to the front-end. I remember a few years back, just because of the technology discrepancies sometimes between the front end and the back end, if you don't write in Node.js, a lot of front-end teams in companies in Barcelona included the API layer as well, just because of the network, the context switch that it meant to change languages. Also, the front-end complexity, even though it's been a few years right now, like 10, 15 years, but it's more recent than the backend one. There were much more complex backend systems before there were any complex front-end systems. And another reason I found is if you have really bad architecture in your front-end, it is less painful than if you had a bad one for the backend. What do I mean? It's still quite bad, but it mainly affects developer experience and UX and the opportunity cost, as I said, of not evolving. Whereas in the backend, it might make things crash and your business to burn. So if there's one thing you focus on, if you have to choose one, usually the backend gets more attention, unless your teams are split. And then that's why I was asking about the full stack. And then one team can handle the backend and the other one the front end. Another one, front-end is much more functional than most backends. There's also functional backends out there, but the fact that we don't have like object-oriented programming with state being stored in different parts makes it so that there's less variability of situations where architecture might get you out of a problem. And the final one that everyone knows, tools have evolved a lot in the front end. I'm talking about frameworks, different state management solutions and stuff like that. Whereas I feel the tools in the backend are much more commoditized. Like there are so many languages, so many tools that do the same in different ecosystems that we have kind of learned to isolate ourselves from them, change the tool as it's needed, but the core can stay. You would say if you're a backend developer in Python, becoming another one in Java is not so complicated. The concepts translate very well because the solutions are usually separated from the tools or technologies that you're using. And when I say the tools have evolved, thanks to ChatGPT research, I did a little bit of digging of the history of the tools in the front end. Front end doesn't start in 2013 when React is released. In fact, Edpuzzle is prior to React. We didn't start the company with this technology. We had Backbone.js at that time. But I felt like reviewing a little bit and very quickly the history of the past 10, 12 years shows and proves my opinions that the tools have evolved so much that we didn't have time to relax and actually think of core architecture. And everything started in 2013, even though React wasn't stabilized until 2015. But React, when it was released, it was super constraining in the sense that we didn't have hooks or anything like that. So the flow of data was completely constrained in the tree of components that the application had. And even the communication between them was always down the tree, never horizontally, which you could do in Backbone in many extremely bad ways. So it was a super constraining environment, didn't give a lot of room for creativity in the architecture. Later in 2013, where Flux-like, Redux-like state management solutions, it was the first time that the flow information could actually be retrieved from the component tree. And then new problems arise because everyone started dividing this new front-end database like they did in the backend, like by type of data. And this caused a lot of problems to many teams. And later there were other best practices like maybe storing the data in the sub-applications that you have, which matches again more the tree of rendering components, but not important. My point here is this was the first time that a little bit of architecture was discussed in the front end with React. And then speed run the next 5 years, there was a lot of things happening. React appeared, so everyone started from a similar base. Functional components appeared, so we all rewrote everything in functional components. Then GraphQL was cool, later not so cool. With Apollo GraphQL, more Redux alternatives. In the end, it's the same database detached from the component tree. In 2017, some universal frameworks, Gatsby, Next.js appeared, and we started moving again, what I said before, the border front-end extended back again into the API layer. Companies who were using React started to get bigger, so things like monorepos started appearing, and we basically had a couple tools also only available to try to separate business logic from UI, which was higher order components, render props, until Context API was actually cool to use because it was always available, but as a secret gateway that should never be used. But that added another tool in our disposal for architecture in terms of injecting stuff, etc., etc. Then hooks came, and again, we rewrote everything. CSS.js was cool. We started to componentize our styles as well. But as I said, all the time we are changing, and the best practices are changing under our feet. 2020 was with concurrent React was the first time you could actually have two versions of React on the same page. Before you couldn't. So thanks to Webpack getting more and more complicated, it added features that only some huge companies were mentioning, like Model Federation. I still don't know fully what it is. That's how it's talked, but it's one of those things that nobody uses. Some people talk about it. Micro frontends, then until CSS was cool, CSS just wasn't anymore. More and more state managers. TypeScript as a default, which matters for architecture because in a functional world where you are passing primitives all along instead of what you usually do in the backend with more object-oriented programming. TypeScript added more ease of mind for developers in terms of making changes. The boundary wars got even worse with Vite and other alternatives. React, now React Server Components, again, everything is a new best practice, even though now we're starting to doubt whether it's a good idea or not. And we are now what I call the framework era. Like even React officially tells you to use a framework and not React itself. But as I said, it's not important each of the lines in this history line. It's more about the front-end world. We're not good at isolating our business logic from the frameworks and tools. And at the same time, the frameworks and tools are changing all the time. So basically, it's not a very good environment to actually be like, okay, we're not going to change for 3 years. How can we make the architecture better? It's just rewrite after rewrite, even though it's progressive most of the time, hopefully. But this is our life in the past 12 years. So as a consequence, and here's a type on the slide, our architecture is more on the fly. And like you let your developers more or less decide at every moment what to do, and you end up with a very huge application, different ways of doing things. It's not clear in the market, and there's no one talking about the set of best practices that you can actually attach yourself. And sometimes you have some intruder from the backend. We're all full stack, so nobody's an intruder, trying to apply the architecture work in the backend in the front end, but you quickly backtrack because you're like over-engineering things. In a way, as I said, it's not a very great environment to talk about architecture. And in Edpuzzle, we suffered the same consequences as everyone else. But in order to understand what we did, the current solution, I have to give you a little bit of context of why we need architecture at all. And mainly, the two things that affect architecture is not just the code and the beauty of it and the craft. It's two forces that are not always synchronized. One is the product complexity, and the other one is the team behind it. As I said before, in companies that raise a lot of money and teams increase, product complexity and team are usually changing at the same time. But other companies, like in our case, where the product complexity grows much faster than the team, this is a force that is going in opposite directions. But as I said, survival bias, most people who write blog posts are from the first kind of company, not the second one. And what is Edpuzzle? Let me give you a little bit of context, even though Flor already mentioned it. Basically, we empower teachers to make learning interactive. It's a product where we have a little story before that, sorry. We started the company in 2013, so we are one of the old ones. It's 4 friends that we know each other since we were 3 years old, basically, that started a website in the classroom of one of us, and Kim, who is back there watching, in his class in Badalona. Just as friends, not with any ambition to make a company out of it. But long story short, we ended up moving out to the US and entering the Y Combinator accelerator to turn this into a product that more people besides Kim students would use. And we started growing quite organically from the beginning in a world in the edtech where edtech wasn't yet cool as after COVID, everyone thinks it is. So it was a world where there were not many success cases or stories to follow. Then we returned to Spain, at least some of us, to build a product team while keeping sales growth and other departments in the US. So we're now still split into the 2 countries and other countries as well. As a quick gist of the numbers, this just, my point here is, of course, the numbers are big and nice and you're going to remember, but it's because I wanted to show that we have a lot of usage. So the architecture also suffers because there's a lot of people using it. So when there's a problem, it's quite amplified. And what is the team behind it? This is one of the things that differentiates us the most from other cases or people who talk about architecture, which is we have a very clear team strategy. We're a company that prioritizes profitability to ensure our future rather than depending on external funding. This is from our beginnings in 2013. There was not a lot of funding going on in edtech, so you actually had to make a business that could sustain itself. So we still extended until now. So as a consequence, and also as a philosophy, we want the team to be the right size. What is the right size? That's an art. But what we have decided from early on is the team has to be the right size. And for that, everyone has to be able to impact any part of the product, talking back and front and any of the features we have. And we need them to be product engineers, one of those buzzwords that is now running as well. Basically, what I translated into is have the user in mind, have as much context as possible. Don't verticalize yourself in one part of the product. And that's very challenging, of course. It's easier said than done, but it's what works for us. If you have a small team, you have to have this. As a consequence, you're going to have specialized people and a very small team because then nothing will move. There will be too much coordination going on. I talk a little bit more about this, or a little more, an hour about this in Pamplona Software Crafters. I share the link to YouTube here if you're interested in that. The talk is in Spanish. And now about the product and going a little bit deep into how it works, the parts that it has, more than just saying what we're doing our mission. And boom, the slide, a lot of text. Let me explain and break it down for you. We basically have 4 kinds of users. I'm simplifying here, but it will be teachers and students, which is obvious. Edpuzzlers, as people who work in Edpuzzle, and school IT admins, which are sometimes the school principal or people who are responsible for technology in their school. It's something that in Spain we don't have as much, but in the US it's quite common. And then we have, again, simplifying, 6 apps that we built with the people in the team, which I forgot to say, but we're around 25, 26 engineers, plus infra, QA, data, et cetera. But we have 6 apps, and different users use different apps. Sometimes more than one kind of user uses the same app. I would say a school admin panel as a dashboard for the school IT admins to manage accounts, see the usage of the tool in the school, also assign content for the teachers to learn as well, et cetera. We have a back office for internal management of different accounts and stuff. Original Studio, which is, we have a department that produces content by themselves. I believe, Kim, correct me if I'm wrong, we've done around 3,000 videos, 5,000 now, big mistake. So we have our own kind of YouTube studio where our team can create the videos and inject them into Edpuzzle so teachers can use them, right? So that's a whole platform by itself. And then we have Edpuzzle Classroom versus Edpuzzle Professional, which is Professional is a much newer product. Classroom allows teachers to basically teach their students, assign interactive lessons, track their progress. Professional does the same for schools trying to make their teachers learn. Either a teacher can choose to learn by themselves, and they also get tracked. The principal can see who watched what, get certifications, et cetera, or the teacher can self-select to learn. In some states, in some countries, professional development is mandatory. You have to track how many hours were invested in that. So we have a product for that, but the core is the same as the Edpuzzle Classroom. And then we have a screen recording and whiteboarding tool to create videos from scratch as well. Inside these apps, there's a ton of features. In the end, as I said, we started in 2013. We are not 2-3 years old, so we have added a lot of power for teachers, like the admins, Edpuzzlers, students to use. This is just the gist of it. Because what I want to say is that we have many features for content, like search engine, because everything is public by default. So we have millions of videos to search for, a video editor online on the website, a quiz editor now, a video player, our own encoding system, streaming system for all those gigabytes of video, et cetera. And as it might happen in many of your companies, many apps use the same feature. They're just packaged in a different way. For example, taking the video editor as an example, or the quiz editor, not only teachers use it in a public classroom to create video lessons or quizzes for their students, but also our own content production team uses it to create it for the teachers to use in their classroom, just as an example. But it happens with more or less painted in red, orange features that are shared between many apps, but just to give you a little bit of view of the complexity. But we have something that is more particular to us than probably your companies if they are not in the education sector, which is all of these apps live in different contexts. What do I mean by that? Not only can a teacher or a student use Edpuzzle through edpuzzle.com, but they can, or through the mobile app, but they can use it embedded in their LMS. What is an LMS? See it as a kind of the Facebook, the wall where teachers and students communicate. So a teacher doesn't want to use 70,000 tools and in each of them tell the student to do something. They have a centralized platform where all the students are there. There's a wall where they can communicate. Probably you've seen that in Moodle and other LMSs in the past, but there are many of them and they are geographically different. In different countries, they have different ones, super fragmented. So we have to live within all of those. There are modern ones like Google Classroom, Microsoft Teams, but there are also older ones like Moodle, Canvas, et cetera. So how does it look like? For example, you might have the feature of viewing a video assignment as a student. You can go to edpuzzle.com, log into your account, see that it's assigned to you, click it, watch it, or it might appear as an iframe already embedded in your LMS, and you just watch it, and it's tracking you from behind, and the grade is going to the teacher. The teacher can go to edpuzzle.com if they want, et cetera, et cetera. The goal here for us is we meet the students where they are. We don't need to require them to create an account, remember the password, et cetera, because students, they are not going to remember the password. So that adds a lot of complexity because seeing the graph, we have, as I said, the 4 types of users that access Edpuzzle as a overall product in many different contexts to use those 6 or more apps, which in turn share a lot of features between them. As you can see, this is a mess in terms of if you don't know your architecture, this is going to be a nightmare to work on. And that's why we're having this talk. And let me index a little bit. I said a few words, but I want you to remember them because I'm going to use them often. So I'm referring to context as the different places where somebody can use Edpuzzle, apps as the kind of buckets of functionality that certain kinds of users use, and sub-app as the different features that are shared among them. Remember this too. And this is only half of the story because we also have a lot of complexity in the backend to support all this. The architecture that you are going to imagine in your heads is we have all this front end and it all consumes a single API, and that API hides all the same complexity or double or triple in the backend. And there's a talk, lightning talk that my colleague Fran did in JSCon Spain recently, so you can watch that if you're interested. But today we're going to focus on the front end only. So what are architecture goals, seeing the complexity that I showed you? First, we need to share sub-apps between the apps in the different contexts where those apps are supported. Not every app has all the features in all the contexts. Some contexts, for example, you have to imagine if you're working on an iframe, you don't want a video editor in there. It's going to be too small and unusable. But it's a combination, and we need to be able to share instead of duplicate or triplicate or 4 times or 5 times, because that list of LMSs is everly increasing as Edpuzzle extends its reach in different countries, states, or new players appear in the market. The second, we have a small team, as I said. We need for every developer to be able to modify any app or sub-app without having to load all the context in their brain at once to be able to move a finger. This is very important, otherwise analysis paralysis is more than guaranteed. And third, because everyone is moving around all the parts of the product, we prioritize for familiarity. Like when you move to a different part that you never coded on, it should look quite similar to other parts that you worked on, unless it has a very specific use case for it to be different. And a shared dictionary. We're all the same team. We don't have different ways of communicating, 10 devs here, 10 devs there. We have to have a very list of clear words that when somebody says them, we understand what it means. So I'm going to describe a little bit our current architecture. Bear with me, this is quite dense. We have the Q&A session as well if you want to ask something. I'm going to try my best to make you grasp it. I'm going to show the folder structure first. I'm going to go deeper and deeper and explain the reasons why we organize it this way. But first, at the root of the application, we have the apps that I showed you in the diagram before. So I changed the names for the puzzle in the room so that everyone understands, but they might have better or worse names in our code base, but this way is a much better for anyone else who's new to understand. And we have the different 6 apps that I showed. There are more, but you understand what I mean. And they are the root. Then we have those contexts where those apps live. So for example, for the classroom teacher, they can use Edpuzzle in edpuzzle.com or in Google Classroom or in Microsoft Teams, Moodle, Schoology, basically every context for the teacher. And those are nested right inside the folder of each of the apps. So all the apps that can be accessed by users in different contexts are included for each of the folders of the apps. For example, for student, it's also all of the context, but for let's say Original Studio, it's only in edpuzzle.com, for example, right? Then each app in each context, because as I said, is literally a different URL that they're going to have to implement authentication in that context. So you can imagine LMSs have, some of them have auth 2.0, some of them have something much older and worse, and we have to be able to support in each of the entry points, kind of the authentication system. And for each app and context, we have a separate namespace in our API. I told you that there's an API for everything, but the way we split it, I'm talking about there's a single entry point in the backend. There's a proxy in there, the requests get distributed, but there's a single entry point to communicate front end and backend. But what we do is for each of the apps and contexts, we have a different namespace in our API. It hasn't always been this way. In fact, we are transitioning there. Also for those Edpuzzlers that say this is not 100% true, but this is where we're going. As a simple example, API/Google Classroom would be the namespace for Classroom Teacher Google Classroom, for say, as an example. And then if you go even deeper, I painted in green these folders because there was no way for me to not mention, I told you, architecture is overall something you have to think of backend and frontend at the same time. We are not split into teams. So we have something called business services in Edpuzzle, which is if we ever broke Edpuzzle into departments, it's quite clear which departments it would be. We have content, we have learning, we have schools, we have business, which would be subscriptions, payments, etc., etc. So we use those words both to organize the folder structure in the backend and also in the front end to group kind of sub-apps that are actually within that context. I was thinking whether to erase this from the slide, but I think it's important anyway. So remember, we have business services in all your companies. You probably have that as well. But within the, if you follow me, we're in the Classroom Teacher app in the context of edpuzzle.com. And then inside, we already have the pages that app in that context has. For example, we have a page to manage the content that you have as a teacher. You have an app to preview a video before assigning it, et cetera, et cetera. And within that page folder, whatever, we have an entry point of the name/page and components folder inside. In a way, what I want you to get here is that we have a recursive folder structure. From here on, we are not very good friends with flat folder structures because even though there's a lot of folders to sometimes open, there's a clarity of the flow of information from the outside to the inside that allows any developer to just follow this pattern and not rethink every time whether something is understandable or not, if the naming is super precise or not, which is kind of paralyzing. And each of the pages here is self-sustaining. So it includes the components it uses, it manages its own state. If it's not using a standardized library that we have for state management, which I'll talk about later, it would be here. So you could basically move this folder anywhere and it should survive. And also an important detail, each of these sub-apps consumes the API namespace of its app and context pair at the top. But as I said before in the diagram, each of our apps uses a lot of the same features and we have to share them between them. So whenever a sub-app is used by more than one app in more than one context or the same app in many contexts, it can be promoted to what we call the shared apps folder. So I just moved literally the same sub-app that I was showing you before. But there's a couple of things that we have to change when we do this. And we only do it when it's shared, not before. And the first thing you have to do is remove their access to the URL. So you might have like links to a specific URL here, et cetera, or even read the URL directly. We remove this and everything's kind of configured from the outside. This is important because in different apps, the URLs are different. So if it's hard-coded inside, you're going to have to pass some ugly prop like is edpuzzle.com classroom teacher, and that grows to infinity. And the other change that we make that is very important is when they get promoted, they also earn their own namespace in the API. This is quite important. And later when we talk about state management, you'll see why. And finally, as an aside, just for completion, there's stuff that is shared, but it's not really a shared app. And the way to kind of measure it is, would it be usable by another website? And we have a few things. You might think that Puzzle API, yes, we could always publish an SDK for somebody to call our API. That's there. Some React hook that are used constantly, use visibility, whatever. It's added here. A video player that can play any source, like the ones we support is also here, et cetera, et cetera. Sometimes they do have to access the API as well. For example, the video player has to retrieve captions, get a streaming URL with authorization and stuff like that. So also they have their own namespace here. We grant them their own namespace in our backend for frontend or layer. So what are the rules and constraints with these pieces that we have? We follow the dependency rule that a file cannot import another file that is not within itself. Like basically, we follow the arrow from the outside to the inside. We cannot import back unless what you're importing is a shared app or a package. And if you're doing that, you're importing their index file. You cannot go deep and retrieve something from the inside. Otherwise, you're not going to allow developers to change it with confidence. And sub-apps and packages must be self-sustaining, manage its own state, API calls to the namespace that we granted them, et cetera, et cetera. But this is very cool. But I saw a tweet recently that says architecture is not your folder structure, because in frontend we have state management. It's one of the biggest topics, especially in an app like ours, where, as I said, we're not a CRUD API read-only interface. We have editors, we have gradebooks, a lot of aggregation of stuff. It's quite complex. So what is our solution for state management, which hasn't always been like this? So we have a default. As I said, familiarity is really important. So there's a standard way to handle state, even though for a specific case, you could veer out of this and use a different technique. But the default is We have an Edpuzzle API package, which we generate from the backend with an API specification. And it's kind of, as I said, the SDK that we could publish and somebody could call our API that way. Then we have another package next to it, which is Edpuzzle API React query, not React hooks, which basically what exports is, instead of ways to call the API, hooks with React query that use our API. So you can see in the structure inside the folder for the different versions of our API. We're running on version v3 right now after, as I said, the 12 years. We have queries and mutations separated, and you can export those. And what the package does internally is manage the consistency of the cache. For example, if you have a list of classrooms, you do a query, you have it locally in the cache of React query, and you do a mutation to change the name of a classroom, it might manage that to make sure the name is changed everywhere in the cache. It's something internal, and we don't have to handle it from the outside. So as I said, it handles cache consistency inside. And this cache is global. So one might say, didn't you have the goal that when you change a sub app, you shouldn't be thinking about the whole thing? The way we solve this is not by doing what we used to do before, which is we used to have Redux with we still have in many places, Redux with different modules where even though you were fetching the same, each module was storing its own cache. So you will have a page where you loaded, let's say, a classroom. And if you navigated to another sub app that also wanted the classroom, you will have to fetch it again. So the UX would be not perfect. The way we solve it now is, no, the cache is actually global, but because we have namespaces in the API, it's the API itself that is breaking the cache into different subsets that don't touch each other. So if you are in the namespace of one of the shared apps and you're fetching stuff there, it's cached, even though it's shared among the whole application, because you're catching the routes of API/learning. It's its own kind of, you don't enforce it in the front end, you enforce it by the design of your API. What are the benefits? First, the realization of all of our problems, or 90% of our problems in the past years with the front end, were due to a bad API design. This is normal because we have been building this API for 12 years, changing the business throughout this process, and we see a lot of flaws. Now, with the current knowledge that we have, we see a lot of flaws. It's kind of fragmented. Sometimes you have to call a couple of APIs to get the information you need all at once, et cetera, et cetera. And this bad design was propagating into our component tree. Now, with this package, basically because we are consuming from the UI, like the hooks that we expose from this package, we have isolated the bad design of our API into this package. So we are now much more ready to go into a V4 with all the new knowledge we have, and later to a V5 once we realize the V4 also is bad. But it's a much better environment. And this is proven by us interacting with the API without having to modify the front-end code so much. One thing that I forgot to mention, though, the different shared apps or the apps use these hooks, but they have the power ultimately to modify exactly which fields they need. The hooks are generic, so get me all the classrooms, but if you want specifically to add an extra field or to remove some, that's something you do in the app itself because it's a necessity of that specific app. But in general, the default is you just get everything, because we're not Facebook here. Facebook is the one who invented GraphQL, and they were losing money by displaying one more field from the post request. This is not us. This is probably not anyone in this room. We don't need to be so specific. Polo GraphQL is kind of an over-engineer mess for most companies. So architecture goals, have we actually accomplished them with this current iteration, which probably won't be the last? I would say the need to share sub-apps is completely as a complete success. We prove this because in the end, a lot of apps in the context, for example, in the LMS, are kind of a middleware. They do authentication and import a shared app, and that's it. That's all they do. And when we add new features, which we are continuously doing, for example, for viewing, video assignments, et cetera, automatically they're available on every context. Can a developer modify an app or sub-app without having to load everything in their mind? Yes, of course, there's still a lot to load, but because of this dependency rule, this is mostly accomplished. And when they have to create a new sub-app, the framework, the ideas are quite clear. We have 4 concepts to remember, and we have design sessions to actually discuss as a team whether something is a sub-app or not, is it shared or not, and those are the moments where we decide. And the familiarity in shared dictionary, this is always a day-to-day work and struggle. Synonyms like to pop up from everywhere. A new person enters the team, and a word that is so clear for everyone else is not for the new person. So you have to work on this. So it's a solved problem, but also an unsolved one. It takes one mistake to break this, but this architecture cannot fix it. Even if you have a dictionary in your Notion that is so clear, somebody won't read it. It's normal. So as I said before, this just have our architecture. We have a lot more in the back end, but that's for another talk. I don't want to make this 3 hours. So yeah, let's go to the Q&A, and I'll leave this slide, which is perfect to take to remind you that we're hiring. The migration is not complete, so if you want to complete it, join us. So any questions that you have, I'm happy to answer. Yeah. Anyone? Yep.
Yeah, very impressive talk. So I was missing something. So you talked about that you had to rewrite the code several times. You started 12 years ago, had a small team. So how do you deal with legacy code? Somehow you must have it, or do you really follow the fashion and rewrite everything?
We don't follow the fashion. I would say you'll always have legacy. It's just that for me, the most important characteristic is when you decide to change a technology or an architecture, you should write the new stuff with the new architecture, and it shouldn't be like a halfway there. It should be like if you didn't have legacy. So you have to find techniques of, okay, for example, when we migrated from Backbone to React, I think there's a talk from many years ago about this. We wrote the new React code as if there was no Backbone code, and we found ways to handle the communication in a way that would be centralized, like new developers didn't have to learn Backbone to make changes. Same when we did the migration to domain-driven design or hexagonal architecture, ports and adapters, however you want to call it. The same, we have more MVC style backend and more like DDD backend, and it's quite isolated from each other, even though it lives in the same machine. We use query buses and stuff like that to hide the legacy. So for me, the important thing is don't do double layer migration. Don't do one that is almost perfect because you have legacy, and once all the legacy is done, which is never, then perfect. Try to make it perfect from the beginning, and then let progression happen naturally, and allow teams to decide whether in their project they should migrate or not, because they have the context of the timeline and the different challenges.
So how old is your oldest front-end code line?
I don't know. I mean, the last week I saw something I wrote myself 6 years ago. I would say recently we killed the oldest piece with a project we did to redo our text editor. It was an image upload feature that was probably like 10 years old or 11. I don't know. Anyone remembers? Yeah, I would say between 6 and 8, let's say. Yeah.
About the number of contexts, how would you say the complexity of your code base scales with a number of contexts that you have to handle, number of LMS systems? Something very important?
Yeah, I would say around 70% of the traffic is through LMSs. So it's one of our core. I didn't talk about that because it's very specific, but we have like 3 main like decisions and goals from our architecture overall. One of them is adding another LMS should be simple, because we go into a market, school is very interested in Edpuzzle, wants to pay, but they use LMS name, whatever. And like, can we not have that contract because of that? And there's a standardized protocol for LMS called LTI. It's 90% standard. So we have actually 2 kinds of integrations, super deep custom ones like Google Classroom, Microsoft Teams, and then through the protocol LTI, we have a lot more. So it's very important for it to be simple. So that's the backend part, but well, the front end as well with the apps and contexts. But in the backend, adding a new LMS doesn't make you modify any previous one. Much like a Zapier would do. It's like plugging in an integration. Yep.
I was looking at the folder that you guys have. I was curious about if you guys have a design system or
Yeah, actually, it's in the package folder. I forgot to mention it.
Where do you see the component being there or not being there?
It's I would say it's a boomerang debate. Like usually our standard is it doesn't grow. We have a set of very basic components, forms, whatever, buttons, everything there that our design team created, and it doesn't grow much. If we have doubts between sharing or not sharing, the default is not sharing, because the goal of you don't have to remember if I'm touching this card here, I have to QA everywhere. it's much better to even stagger the release by having to modify it everywhere. So, but this debate reappeared even this morning. So there's always this tension, and you have to kind of check your values, whether you agree with yourself again or not. Yeah. Anything else? I think enough. We can go have dinner, chat, whatever. Thank you for coming.